Hi, this is Shannon Seaver, and I'm here to talk to you about truth tables for negation, conjunction, and disjunction, part 2. Today we're going to talk about what a tautology is, construct a truth table for 3 statements, and determine the truth value of a compound statement for a specific case. So first of all, let's talk about what a tautology is. It is a compound statement that is always true. To explain this a little further, let's look at an example. We're going to construct a truth table for P or not P. First of all, the 2 possibilities for P are true and false. So I'm going to put those here. Remember, not P is always the opposite of what P is. So here we have true, not P will be false. In the first column we have false, so not P will be true. And then, if you remember, for an OR statement, they both have to be false in order for this column to be false. And notice that they both have at least one true in it, so the outcome for both of these cases will be true. Since that everything here is true, it is a tautology. So anytime you see all trues in your final column, that is a tautology. Let's look at another example, not about tautologies, but let's look at something about 3 different statements within the truth table. So here we have, I study hard. That would be your P statement. And ace the final, here's a connective. Ace the final is the Q statement. Notice we have a comma, we have an OR, and then this statement, I fail the course, is your R statement. So I could write this as P and Q or R. I have the parentheses there because of the comma. So we want to construct a truth table for this specific case. We'll come back to B in just a minute. So let's do that. Notice that P can be either true or false, and same with Q and R, but we need to find every combination possible for P, Q, and R. So I'm going to start off with the P column being 4 trues and 4 falses. And I recommend you set up your 3-statement chart the same way. Then we're going to go to 2 trues and 2 falses, 2 trues and 2 falses. And then in the R column, we will do every other. So T, F, T, F, T, F, T, and F. The reason why I have it set up in this pattern is to ensure that I have every possibility for all 3 statements, all the different possible combinations. Okay, so this is our basic thing that you have to have set up for a 3-statement truth table. So make sure you have that every time. Now we're going to talk about P and Q. Remember, in order to have an AND statement be true, they all have to be true. So here we have all trues right here. So we're just looking at this column now and this column because we are talking about P and Q. So this one's going to be true here. Notice it's also true on this one. So this will be true on that case. But the rest of them, because they're not both true in both columns, will be false. On the final column, we need to look at this column right here and the R column. So I'm going to change my pen color here just for a second. That's fine. Let's do green. So this is the column we need to look at, and this column. We want to do OR. Remember, the rule for an OR is that both columns have to be false in that row. So let's look down the column and find 2 falses. We have one right here, and we have another one right here. Remember, for an OR, if they're both false, the outcome's a false. We also have another one right here. So that will also be a false. But the rest will be a true. So we have our truth table set up. Let's take a moment and go back because there was a part B to this question, and let's see what the part B is. So it says, suppose you studied hard, so that would be truth for P, and you do not ace the final, so that would be a false for Q, and you fail the course, that would be a true for R. What is the truth value for these conditions? So I want to go to my table and look up TFT. Let's find that. I believe this is our TFT right here. And there is no other instance of that. Our outcome at that point is true. So in order to answer this, what is the truth value for these conditions where P is true, Q is false, and R is true? It's true. Now for the last example, let's look at this one. It says college administrators and public health officials and parents increasingly have become concerned about safety of college students after highly publicized deaths on campus from alcohol abuse and other causes. The data in figure 3.3 indicate that freshmen are uniquely vulnerable. Here we have two pie charts that give us some information. Use the information in the circle graphs to determine the truth value of each of the following statements. Okay, so the first one, it is not true that freshmen make up 24% of the undergraduate college population. We have an and here, account for more than 1/3 of the undergraduate deaths, a comma, or another connective, seniors do not account for 30% of the deaths. So let's look at the very first statement. It is not true that freshmen make up 24% of the undergraduate college population. If we look at our chart, we see that freshmen do make up 24%. So the fact that they're saying that that's false, that's a false statement. So I'm going to write false here. We have an and, so I'm going to put an and, account for more than 1/3 of the undergraduate deaths. Let's look at freshmen. That's 35%. That is more than 1/3 of the undergraduate deaths, so that'll be a true. Notice we have a comma, so I'm going to put this in parentheses. We have an or now. Seniors do not account for 30% of the undergraduate deaths. So let's look back at that percent of undergraduate deaths, which would be this chart, and seniors. Seniors do not account for 30% of the undergraduate deaths. Well, seniors are 20%, so that is a true statement. So the question is, what is the outcome for this specific case? Well, we know that F and a T, because it's an and statement, in order for the outcome to be true, they both have to be true, so that's going to be a false. And I'm going to rewrite it like this. Now we have an or statement. In order for the outcome to be false, they both have to be false, so the outcome is a true. Now I want you to try. Using the chart on the slide before, determine the truth value for the following statements. Take time to pause the video, look back at the chart, and then try to come out with a truth value after determining what the truths are for each statement. So after looking at the chart, I determined that freshmen and juniors make up the same percentage of undergraduate college population was a true statement. Then we have an or here, and the or said that seniors make up 35% of the population. That was a false statement based on the earlier pie charts. We have a comma here, so that tells me that those two statements have to be inside a parentheses. And then we have an and it says freshmen and juniors do not account for the same percentage of undergraduate deaths. Looking back at the pie chart, that is a true statement. So we're starting off with this. Now at this point we need to look inside the parentheses. notice that we have an or, and in order for the outcome to be false, they both have to be false. So we are going to take true or false. That will be a true statement. And T. Now let's look at both of these. We have an and. In order for both ands to be true, the outcome to be true, they both have to start off being true. So the outcome for this particular one is a true. Let's review. A tautology is when everything in the last column is true. Constructing a truth table for 3 statements, remember that you would set up your truth table where you have a P, a Q, and an R, and you'd have 4 trues, 4 falses. And we would have 2 trues, 2 falses, and a true and a false alternating. So remember, when you're setting it up, that's the first thing you're going to do. Lastly, determine the truth value for a compound statement for a specific case. First, you need to determine if that specific statement is true or false, and then use the rules of and or statements to figure out the outcome. That is it for today.